We've been hearing this morning on Newsday about new evidence of our warming world. For the first time, global warming has exceeded 1.5 degrees Celsius across an entire year. That's according to new data from the EU climate service Copernicus. Limiting long-term warning to 1.5 degrees centigrade above pre-industrial levels before humans started burning large amounts of fossil fuels has become a key symbol of international efforts to tackle climate change. And at least for this one-year period, it has not been achieved, adding to the concerns that we are missing global warming targets. So, could developments with a massive space umbrella save us from the worst effects of global warming? It might sound like science fiction, but it's an idea that's been around for a while in research circles, and now a small but growing number of experts are pushing for the idea to be taken seriously. And our next guest is actually working on a prototype of a working sun shield and joins us now. He's a physics professor, Rozen, of the Asher Space Research Institute at the Technion Israel Institute of Technology. Welcome to the programme. How would this work then?
Good morning. Just like an umbrella. You know, when you hold an umbrella above your head, you have shade. The problem with holding an umbrella or even entering your house where it's shaded is that you feel better, but it doesn't change anything to the world. So we have to do something outside of the atmosphere. And the best place, or the only place to put it, is about 1.5 million kilometers from Earth towards the sun. It's a point called Lagrange point 1, where the gravitational forces balance each other, the gravitational forces of Earth and the Sun. Therefore, a body put there can stay, under certain conditions, can stay and constantly rotate around the Sun with Earth, constantly providing shade.
You say put a body, put what exactly up there?
The final idea is to put a large parasol or a collection of parasol, blankets, umbrellas, whatever you would like to call them, that together the total area will be 2.5 million square kilometers. This is roughly the size of Kazakhstan or Algeria or Argentine. Pretty big, I must admit.
Yeah. How do you make something that big? How do you get it that far?
Okay. First, as I mentioned, we're going to do it it's going to be modular. We're going to do smaller pieces, and they're going to be built as light as possible with the lightest material possible. Usually, we are talking about a very thin film, the type that marathon runners are getting when at the end of a run, to keep their body warm.
Yeah.
This super thin film, yes.
But presumably something that is 1 million square miles, 2.5 million square kilometres big would be incredibly heavy, however thin that was. So there would still be huge difficulties in transporting it that far.
Okay, yes, absolutely. The weight of the sail itself, the blanket, is going to be above 2.5 million tons. That's quite a lot, and that is part of the reason why we have to do it in stages, like modular. But still, it's a huge, huge undertaking, and it's definitely going to be humanity's biggest project ever.
Yeah, you're at the testing phase. You're asking for money to carry on with these tests. Do we have time for all this? The planet is running out of time pretty fast.
Correct. We believe that we can build our prototype of 10 square meters to demonstrate that everything is possible, that we have the technology to control it in space, shading, well, not providing shade, but increasing it to provide shade within 3 years of securing funding. The large project, like the big parasol, that is probably 2 decades away.
Okay, but you believe that within 2 decades a system could be built that could cool the world down sufficiently to avert the worst effects of global warming?
Yes, I think so, and I certainly hope so. If we are not going to build this demonstration unit, I doubt that somebody else will start with the big thing. But if we do show the world that we can do it, then maybe the world will pick up the tab and build it.
Would it throw the entire planet into darkness? I mean, what sort of effects could it have?
Excellent question. No, we're gonna put shade of about 2% to reduce 2% of the solar radiation. 2% is really nothing. And because of the distance, the shade will be very, very diffused over Earth. It will be mostly equatorial, but super diffused. You're hardly going to see it or feel it, just like when a bird flies above you. If it flies 100 meters above you, you don't see the shade on the ground. So this is sort of the type of effect that we will see, but it will reduce the radiation amount by 2%, what is needed.
Yoram Rozen of the Asher Space Research Institute at the Technion Israel Institute of Technology, thank you very much for explaining your idea. We'll see what happens. This is Newsday on the BBC World Service.